Hi, this is Professor Evans. This video is for the students in COP 3330C, which is Object-Oriented Programming at Valencia College in Orlando, Florida. In this video, we're going to discover collections using Java and IntelliJ. The learning outcome for this video is that students are going to learn how to use the major classes in the collections framework, along with creating a simple user interface that listens for and responds to events. So just as a reminder, this video is meant to go along with the other resources that are provided online within our course. As a future software developer, one of the critical tasks you're going to need to know how to do all the time is read through documentation and learn from it. So that's a skill that we've implemented into the course. So just a friendly reminder to please make sure you have read through the textbook and any other tutorials or articles that have been posted online before proceeding to watching this video. Once you're ready, please open your IDE and write code along with me. This will serve as a springboard for getting your programming project started for this module, as well as giving you a resource to study from for future exams. So let's start with our definitions. What is a collection? So in Java, we have this concept of a collection. It's an object that represents a group of objects, which is called a data structure. So we have this idea of a collection. It represents a group of objects. Then we also have the Java collections. Notice there's an S on the end of that. The Java collections framework. And that includes interfaces like list, set, and map, as well as classes like ArrayList, LinkList, HashSet, and HashMap. The collections framework gives us a set of tools, such as static methods, that allow us to manipulate a collection. And those methods could be things like sorting or locating a particular object within your collection, etc. So today, we're going to look a little bit into the Java collections framework and see how we can use that framework in order to manipulate a collection. So you will want to do some research on the Java collections framework. I'm just going to give you a little snippet of that research down here. For example, the list, set, and map interfaces are right here on the screen, and you can sort of read through those to see what some of the differences are between the two. For example, list offers index-based ways to add, update, remove, and search for elements, and it maintains the order of the elements in your list. Meanwhile, a set offers an unordered approach, so you don't necessarily have an order of elements with a set. A map stores data using mapping, and that's the idea of a key value pair. These are all interfaces that you can implement using the Java collections framework. Again, you will want to research the other classes that are available within the collections framework. For example, ArrayList, LinkList, HashSet, and so on. So the collections class, as I said before, is a utility class in java.util.package. It provides static methods for common tasks, such as sorting and searching. So as a reminder, a static method does not require instantiation in order for it to be called. So here's a code snippet at the bottom here where we're just doing a quick example. Within our main method, we're creating a list of integers. We're naming that list number, and then we're going to add some integers to the list. Let's say that I want to now sort this list from least to greatest value. I can call collections.sort and pass in my list in order to sort my collection. Notice that I didn't have to instantiate an object in order to call this method sort. That's because sort is a static method, so instantiation is not required. So the collections class offers a lot of static methods for common tasks that you may want to do on a collection. Let's take a look at that real quick. So this link here is to the documentation on oracle.com for Java, and this is the collections class. If you read through this, you can understand the framework for collections that Java has set up. And if you look at the method summary, for example, you can click the static methods tab, and you can see all of the methods that you can invoke for a collection. So if you read through these, you can get a quick description of what it does, as well as the arguments. So I just called collections.sort. So if I scroll down here, Here's my method sort, and then you can even click this name to learn more about that specific method. There's shuffle, rotate, reverse order, reverse, replace, etc. There are lots of static methods within the collections framework that you could use to modify a collection. So when it comes to understanding collections in Java, we have a lot of different terms, and it's important to sort of understand the differences between some of these terms. For example, let's say we're considering an array, which can also hold a series of data points, versus a collection. What are some of the differences? An array is considered a simple fixed size data structure, and it has to hold elements of the same type. A collection is more flexible, it's more dynamic, it can grow and shrink in size and hold objects of different types. And collections also come with more utility methods. So if I create an array, I don't necessarily have a quick and easy way to sort that array in reverse order. I would have to perhaps write a method in order to do that. But with a collection, I can go to the collections framework and use those static methods that are available to modify the collection. So that may be a reason why you choose to create a collection over an array. And then we have concepts like list and array list. Again, these are things that you'll want to read through using the documentation provided, as well as looking at the collections framework online, the link that I just showed you. You will want to read through and sort of understand some of the nuances between all of these terms that are related to collections. So just as a quick summary, a list is an ordered collection that can contain duplicate elements. Array list is an implementation of the list interface. So we have list, which is an interface. We can implement that interface using an array list, and it's backed by a dynamic array. And it provides fast access and insertion operations. In the example I'm going to show you today, you're going to see how we implement a list by creating an array list. And then we're going to use that to create our collection. So today's example is going to be the Guardians app. This exercise will demonstrate some uses of collections inspired by Guardians of the Galaxy. In this example, we're going to create an array list and demonstrate how to add elements to the list and sort the list using the collections class. I'm also going to show you how to write your own custom sorting algorithm using a comparator. And then we're going to convert the list into an array. This is just an example. Your programming project is going to require additional functionality. This example is just to get you started with your programming project. You will have to research the collections class to find other static methods you can use to meet the requirements of your programming project for this module. And with that, we will get started. All right, so I have a brand new project open in IntelliJ. And I am going to just create one class called Guardians app. And I'm going to add my main method right here, and then we'll get started. So I'm going to add a comment at the top with just a general description. All right, so there's a quick description of what I'm expecting this program to do. And the first thing that we're going to do is create a list of strings, because we're just going to be adding character names to our collection. I'm going to call it Guardian. And I'm going to call it an array list. Now, I'm going to need to import some files in order to use list and array list. So if you see an error in IntelliJ, you can select this option to import the class that is required, and it'll automatically import the classes that you're missing. So these are two of the classes we're going to import. in order to modify our collections today. I'm just going to add a quick comment up here at the top. Just as a reminder that list is an interface. So list is an interface that represents an ordered collection. Array list is an implementation. Array list is an implementation of the list interface that uses a dynamic array. So we have our list called Guardian, and now we're going to add some elements to the list. So I'm going to call it Guardians with an S. So I'm going to add Star-Lord, Gamora, Drax, Rocket, and we can't forget Groot. So this is going to add some elements to the list. So by declaring guardians of this type here, we get access to these methods, one of them being add. You can see here if you hit the dot operator, you can look at some of the other options that you have for methods that you can perform on your list of guardians. So that's other things that you can research and play around with. So we've added some elements to the list. Next, we're going to sort the list using a static method from the collections class. Reminder, static methods mean we don't need to instantiate an object to use them. All right, so we're going to call collections.sort to sort our list. Notice that in order to call collections.sort, I do need to import the java.util.collections class. So now we can go ahead and just print this out and observe the sorting functionality. Okay, so in order to print, we can use an enhanced for loop. Actually, let me back up here. I'm jumping ahead in my example. We don't need a for loop yet. We're just printing out the list, and we can do that right here because the list type has a toString method already available. So I'm going to run this, and we can see our list of guardians. And it's sorted in alphabetical order. So just to prove that the sort does actually sort, I'll print it out once before the sort and then once after. So before the sort, the items were added in the order that the lines of code were called. And then after the sort, we can see that they're sorted in alphabetical order. All right, the next thing that we're going to do is convert the list to an array. So right now we have a list. We're going to convert it to an array. So I'm going to create a string array. And I can call this toArray function from the Guardians collection that we've created. And that's going to convert our Guardians collection into an array and store it in Guardians array. And now that we have an array, this is where we need that enhanced for loop. That will iterate through the array and print everything out. So why are you being asked to convert the list to an array? Just so that you can compare. So for example, with a collection, once I've added everything to the collection, in order to print it out, I can just pop the collection right into my print statement. With an array, in order to print everything out, I need an enhanced for loop to go through each element of the array to print it out. So I'm going to go ahead and run this just to show its execution. So we have our list unsorted, our list sorted, and then our array sorted, printed out one by one. So we've covered a few functions of what you can do with list. We've covered add and we've covered sort. Remember, it'll be up to you to review the collections framework to do more things like remove or reverse sort or update. So those are things that you will have to research for your programming project. The other thing you're going to be asked to do in your programming project is to create a custom sort. So I am going to create a custom sort and show you how that can be done. You cannot use this particular piece of code in your programming project. You need to do your own idea of a custom sort. And it really can be anything. For example, I'm going to choose to custom sort by the number of vowels in each name. So the name with the least amount of vowels should be first. The name with the most amount of vowels should be last in our sequence of our list. That's what I'm going to add. Again, when you do your programming project, come up with your own unique custom sort, but I am going to show you how you can use a comparator in order to create a custom sort. I'm going to start by writing a static method to count the vowels in a particular string. So I'm declaring this just outside of my main method. So I'm declaring it just outside of my main method, but still within my class, so that this class can call this static method. So it's called count vowels. We're going to start with an integer called count. So this comment explains what I'm about to do next. So I'm going to use an enhanced for loop where I'm going to define a character called C. I'm going to take the string name that has been passed in, convert it all to lowercase so that I can basically make everything case neutral by converting everything to lowercase, so we don't have to worry about an uppercase a versus a lowercase a. And then I'm going to convert that to a character array. And that's what this for loop is going to traverse through. So this for loop is going to take the string name, convert it all to lowercase, convert it to a character array, and then iterate through it and store the value of each character within the array into this temporary variable called C, which is a character. So what we want to do is iterate through the array. And if our character is an A, or our character is an E, or our character is an I, or our character is an O, or our character is a U, then we found a vowel that we need to count. And once we complete this for loop, we're going to return the number of vowels that were counted. So the first part of my custom sort is to figure out how to count the thing I want to compare each object of the list by. I need to compare by number of vowels. So the first thing I need to do is count the number of vowels. So I need a method to do that. And this is how I'm going to do that. So that's my first step. My next step is going to be to use collections.sort again. It's an overloaded method, so it's got a number of options, and one of those options is to pass in a comparator in order to sort by. So I've called collections.sort here, and then we've printed it out, and I'm going to go ahead and just make some space down here for our custom sort. All right, so in order to do this, I'm going to call collections.sort. And notice that I have two options here. So that we've already used the first option where we just pass in a list. The second option allows us to pass in a list and then something called a comparator. That's what we're going to do here. So I'm going to pass in guardians. And I'm going to define a new comparator that's going to be of type string. You will need to import the comparator class in order to use this. So now it's been imported. And I'm going to pause here to give you some more context into what we're doing. So I have a really long comment. I'm going to copy and paste this in so that I can just read through it to you. All right, so comparator is an interface that defines a compare method for custom sorting of objects. So why is this red? Because I'm using an interface and I have yet to define the compare method. So the next thing that I'm going to need to do is define that compare method so that I can get rid of this error. So for this implementation, we're going to override the compare method to return the difference in the number of vowels between two string objects, between two names in our list. So I'm going to pause right there and I'm going to write that override method. Oops. There we go. So here's my compare method that I'm overwriting since I'm implementing the comparator. I'm going to pass it two strings. We'll just call it object 1 and object 2. And what we're going to return here is the result between count vowels for object 1 minus the result of count vowels for object 2. Just fixing some syntax errors here. All right. Just a couple of syntax issues with my brackets, but I fixed that now. So you should have collections.sort, guardians is one of your arguments, and then the new comparator is your other argument, and open close parentheses, and then a bracket here, close bracket there for your compare method, close bracket there for this bracket, and then a parentheses there, and a semicolon. This is all one instruction, but separated into multiple lines so that you can see what's happening here. So I am declaring the compare method to return the difference in vowels between object 1 and object 2. So let's go back to our detailed comment here that's going to give you more information on what's going on. So again, in this implementation, we override the compare method to return the difference in the number of vowels between two string objects. The collections.sort method uses this compare method to determine the sorting order. So for each pair of elements in the list, so we'll start with the first two elements in the list, and it will compare their vowel counts using the overridden compare method that we just wrote. The list is then going to be sorted based on this comparison. So if we have a negative result from this line right here, it indicates that the first string has less than the second. A positive result indicates that the first has more, and 0 indicates equal vowel counts. So it's going to use this information by comparing two objects at a time to determine the sorting order. So this process, it iterates through the entire list using the comparator to determine the final sorted order based on vowel count. So it's a long, detailed explanation, but it really kind of fills you in on what's happening here. So the compare method is just going to take two strings, compare them, and return the difference in their vowel count. Now, that difference is going to be used within the sort method to determine how to sort this list. So that's our custom sort. So now that we've created our custom sort and called it, let's go ahead and print out the results. And let's run it. And here's our output. So we have our unsorted list, our sorted list, which is alphabetically sorted. Here's our array. And then here are the guardians sorted by number of vowels. So Drax has one vowel, Groot and Rocket each have 2 vowels. Star-Lord also has 2 vowels. So these are all in the middle. And notice that our 3 elements in the middle are also in alphabetical order within that middle spot. So they all have the same number of vowels, and G comes before R, comes before S. And then Gamora has 3 vowels, so she is last. And that is how we do our custom sort. Okay, so that concludes our example where we've discussed how to create our list, define it as an array list, and add elements to the list, sort them, create a custom sort, and convert them to an array. Again, your programming project will require additional functionality and your own unique custom sort that does not use vowel count as the method to sort your list. So if you have any questions, please feel free to reach out to me. There's my contact information once again on the screen. I'm happy to answer questions or support you in any way that I can. Let me know how I can help, and happy programming. Until next time, we'll see you later.